let's get started with 3.1, factors. Okay, now this is not a new word for us, factors. Remember, if factors are the two parts of a multiplication problem that are multiplied together, and whatever that equals, that is the product. Oh, there we go. What the heck? Spelling is not my forte, but that was awful. Product. There we go. Product. But the factors would be these whatever values you have in those two spots right there, okay? So factors, when we say factors, we're really saying we're looking at values that multiply together to create a product. Now, for the most part, we've only looked at two factors at a time, and for the most part today we will as well. But it is possible to have three factors, or of course, four factors, and so forth. Okay, you can have more than two or three factors at a time, but you should always need at least two factors. So, well, I guess I'm just pointing out that this is not a new word for us, and I hope that that helps us to understand what we're talking about when we say factors of values. When we talk about factors of values, we're really looking at factors of products. So it is possible that the multiplication facts or the fact families will come in very, very handy in this particular section. See, our objective, determine when a number is prime, composite, or neither. So before we get into factors, it's important, well, I guess this has to do with factors, but prime numbers is where the product is only has two factors, and that would be one in itself. Now that should sound familiar as well, okay? One and itself means that since we are talking about factors, we are also talking about multiplication. And when you take a number and multiply it by one, that is the identity property of multiplication specifically. So a prime number indicates that you could only see that you would have the identity property in order to find its factors. Composite numbers, though, not only will you'll have one in itself be factors, but you'll have other values as well. For example, a common composite number is 10, right? For example, you'd know, first off, you could take 1 times 10, right? And 1 times itself is itself, right? 1 times anything is itself. So that would work for any numbers. But if I can find any other pairs of values that multiply together, then it would make it not prime. So like if you said this was the only set that could make it, these are the only two factors that would make it a product of 10, then we'd say it's prime. But we know there's other factors such as 5 and 2. 5 times 2 is 10. And just the fact that we have this second set of factors makes this a composite number. So a very common prime number, though, if we looked at prime number, would be like, well, 5, okay? For example, just by the identity property of multiplication, I know 1 times 5 is 5. And that's good. That's good to know. That's going to be important. But is there any other two factors that I could multiply by 5 to get itself? And you could say yes if you wanted to include decimals or fractions. However, we're focusing on natural numbers, so we should not see any decimals or fractions of these. Not only because we haven't seen them in this class yet, but we have specified that we are looking at natural numbers alone. And anything greater than 0 without decimals is a natural number. So that's why 5 is a prime number. Of course, there's a big list of prime numbers like 2 and 3. 4 is not prime, of course, but 7 is, and 8, 9, 10, 11 is, 13, 14, 15, 16, 17 is. There's more, of course, but that's a good start. So these are all prime numbers, and the list continues on. It actually goes on forever as far as we know. But you'll notice that 1 is not included in the list that I put in here. That's because 1 is not prime, but it's also not composite. That's because 1 is a very unique number. Like if you talk to math geeks and math nerds, maybe it's the same thing. But if you talk to math nerds about 1, they could go on and on about 1, right? Like, and they would talk about the identity property and how beautiful it is, and they would, you'd think that they were crazy, but it's all within the spectrum of mathematics. So 1 is neither prime nor composite. It's a very unique value, this 1. And you could say, well, why is 1 neither prime nor composite? And you could think about the identity property, right? Well, 1 times 1 is 1. Well, the question becomes, well, which of these 1s is the identity portion? Is it this one, or is it the first or the second factor of 1? And the fact that you can't really make that determination means that we would say, well, it's not prime. And it's definitely not composite because we know that there's no other factors of 1 other than itself in 1, I guess. But again, that's why it's not prime either. Okay? So it is possible from time to time, you'll see this on the homework or quiz. Is 1 prime or composite? They have to give you that third option of either not applicable, does not exist, something like that, or just neither. And yeah, the answer to that is neither. But for the most part today, we're going to be focusing on prime and composite numbers, though, not 1 itself. So a little bit of new vocabulary here with prime and composite numbers, but and yeah, I don't know that these are so so utilized in applications in your everyday life. But I think that a lot of students have at least heard of a prime number. Maybe they don't know what it is, but maybe the wording, at least you've heard it before, which is at least a good start. So in helping us determine if numbers are prime or composite, we go through divisibility rules, okay? Now, these are specific divisibility rules for these specific values. I will tell you that the most common ones that we look over is 2, should highlight that, 2, 3, 5, and 10. And you may be wondering, well, why do we not really worry so much about 4 and 6 and 9? Well, 9, in order for something to be divisible by 9, it's divisible by 3 twice, is really what that comes out to. Okay, and yes, we can use the rule. We'll talk about this rule here in a second, but it may not make sense if we go over it yet. 6, we don't really worry about 6 because it's depending on if it's divisible by 2 and 3. Okay, if we know that a number is divisible by 2 and 3, then it's automatically divisible by 6. Bam, that's kind of the rule. But again, we don't really focus on, hey, is this number divisible by 6? We can focus on these other two to begin with. And the same is true with 4. It just has to be divisible by 2 twice. And so you notice that 9 is a multiple of 3, so that's why we focus on 3 first. 4 is a multiple of 2, which is why we focus on 2 first. Now, when determining if values are divisible by other values, this is a very good list to start with. But another list, another 2 values, they just don't really have rules that apply, at least today, would be 7 and 13. 11 is kind of it's kind of a dark horse on this one. We don't see it too often, but it does come up from time to time. 7 and 13, though, I would say appear more often than 11. Again, it's not that they are common. It's just that they're going to show up from time to time so that it's important to know if a number is divisible by 7 or 13 or 11. Now, to do that, again, the 7 shouldn't be too bad because we should have the first 12 multiples of 7 memorized. Same with 11. 13, though, when we figure out numbers or look at numbers, it may be important just to have the multiples of 13 in front of us, and we can make that offhand. But we're going to be focusing on these these rules up here. Okay, not really 7, 13, and 11. So I'm going to erase those for now. Now, to determine if a number is divisible by 2, and that's usually the number that I start out with. Can I just make the determination if a number is divisible by 2? Because it's very easy. It's just a visual check to see if a number is divisible by 2. So I start usually with 2. And all you're going to do is look in the ones place value. Is there an even number? Even numbers are 0, 2, 4, 6, and 8, just like we see in that list. If in the ones place value I see those numbers, I automatically know that it is divisible by 2. Okay? So if I don't see those 5 numbers right there, I automatically know that it is not divisible by 2. So if it is not divisible by 2, then, so the next one that I would check on this is 5. All right, so I check my 5. And again, the reason why I go to 5 next is because it is a visual check. Again, we're looking at the ones place value. Do I see a 0 or 5? If I see a 0 or 5, then I know that it's divisible by 5. And you may say, well, I thought 0 was in the 2s. That's true. So really, I would only be looking at the 5s. And by doing those two, just starting with those two, it actually checks off the 10s for me. Because for 10s, again, this is just a visual check. Is there a 0 in the ones place value? Because if there is, then I know it's divisible by 10. Which also means if you see a 0 in the ones place value, that it is automatically divisible by 10, 5, and also 2. So that means you have some choices. Would you prefer to divide by 2, 5, or 10? Choice is yours. But again, that's only if you see a 0 in the ones place value. If I don't see any of those values in the ones place values, then I move directly to the 3's. So I would say, hey, look at my 3's. Is this number divisible by 3? And to make that determination, all you have to do is look at the sum of the digits. That means every place value, what you're going to do is you're going to find the sum. That's addition. So you would add all the place values together, and that sum, if that sum is divisible by 3, then you know that the original value is divisible by 3. Well, let's say that you didn't know if the sum was divisible by 3, which can happen from time to time. You can just add the 2 digits or the many digits in the sum together and see if that number is divisible by 3, and you can repeat that process until you either get 3, 6, or 9, and then you would know that it's divisible by 3. Okay. So right there, just from the 3's, it's important to know at least your 3 multiplication tables. Again, it's nice to do it up to 12, but for our purposes today, you only really need the first 3. Now, 4, again, a number has to be divisible by 2, but you'd have to do it twice. We'll get more into that. I don't really worry about the rule for 4's because if something is divisible by 4, it is automatically divisible by 2. Again, same with the 6. If something is divisible by 2 and 3, then I know it's divisible by 6, but by checking with 2 and 3 first, it kind of checks off the 6. So I don't really worry about the 6. The 9, again, you can find the sum of the digits, which is the rule here, and see if that's divisible by 9, which would be a good way to check. But again, if you just see if it's divisible by 3 first, usually you'll find that it's also divisible by 9 at the same time. Of course, not all numbers that are divisible by 3 are divisible by 9. But if a number is divisible by 9, it will automatically be divisible by 3. So just like I was saying before, you just kind of do the 3 thing twice, or maybe you would see right away that the sum of the digits is divisible by 9. Now that to me, that seems like a lot of information right there. So if you're struggling with that, just know that it does take some time, not only to solve the problems like this, but to get used to these rules. But again, we're going to really focus on these first, on the 4 that we talked about right there. Again, maybe you could say 3 because it's 2, 3, and 5. Maybe 10 is kind of obsolete because it's consumed in the 5 and 2 ranges right there. Now, I just kind of want to pull out an example first, okay? Just randomly, by the way. So I do want an even number in the ones place value, but let's just work with some other numbers like a 2, 3, I don't know, 5. Sure, that seems okay. So first off, let's just go through our rules on this, okay? And that's what we're going to be doing for all these values, which we'll see these examples of. But I would know that this 5,328, it's divisible by 2 because I got an 8 in the ones place value. Automatic, divisible by 2. Now again, I say that I go directly to 5, and I see in the ones place value an 8, so it's not divisible by 5, and I could check that off. It's not divisible by 10 because it doesn't have a 0 in the ones place value, so you could cross that one out too. So I would check the 3's though. Now to see if it's divisible by 3, the rule is to find the sum of the digits. What that means is you're going to add all these numbers together and see what you get. Okay, so that would be like, I'd say starting with 5 plus 3, that's 8, then add the 2, which is 10, and then add the 8, which makes this, should have written smaller. That makes that 18. That would be the sum there. This equals 18 right there. And maybe you know that 18 is divisible by 3, which we hope you do. But let's say that you didn't. Well, then you can go to 18 and repeat the process. 1 plus 8 is 9. And I know 9 is divisible by 3. So I would say, hey, this 5,328 is divisible by 3. I also got a sum of 9, so I also know it's divisible by 9 at the same time. Well, since it was divisible by 2, since I had an 8 in the ones place value, and I just saw that it's divisible by 3, so there's the 2, but it's divisible by 2 and 3, which means it's divisible by 6. So this would be in a good way to determine if numbers are composite or prime, because if a number is divisible by any of the values in this list, then it is automatically composite. If it's not, it doesn't mean it's not composite, or it doesn't automatically mean it's prime, because there's other values, of course, not on the list. But these ones have very specific rules, nice rules to work with, as long as you're looking for divisibility. So I just want to reiterate, as you guys are doing these types of problems, just know that it is common to take a lot of time on this. You have to go through the rules until you get used to them, and then you'll get a little bit more speed out of it, which will hopefully in turn create a little bit more convenience for you. So let's go through each of these. I'm going to start with 37. So 37, we're just determining if it's prime. If it's not prime, we'll still say that it's composite though. And again, while we have these rules, I do want to reiterate that we should check for 7, 13, and 11 on these, okay? Because sometimes they'll be divisible by 7, 13, or 11, which don't have rules for us, but it would be important to see those nonetheless. So 37, again, I start in the ones place value. I do not see an even number in the ones place value, so it's not divisible by 2. In the ones place value, it's a 7, so it's not divisible by 5 or 10. So I got those crossed out. Now, since it's not divisible by 2, again, 6 needs to be 2 and 3, so it's not divisible by 6 either. I can cross that out. So let's go and add those two numbers together and see if it's divisible by 3. 3 plus 7, that would be 10. 10 is not a multiple of 3, so I can cross the 3 out. Now, since it was not divisible by 2, it's automatically not divisible by 4 either. And since it's not divisible by 3, it cannot be divisible by 9 either. So you see here, 10, by the way, is not a multiple of 9, so that's another way to look at it. So I would want to just check with 7, 13, and 11, right? Well, 37 is not a multiple of 7, right? The closest multiples of 7 that are close to 37 are 35 and 42, neither of which are 37. So it's not 7 either. What about 13? Again, it's common enough where maybe we should just have our list down here to the side. 13 is our first multiple, plus another 13 is 26. I'm not showing all the work here, although you could. 26 plus 13 is 39, plus another 13 would be 52, and then plus another 13 is 65. I'm going to stop there. I did go too far. We just wanted to get up to 37, and once we got to 39, we could have stopped. So we see that 37 is not a multiple of 13 either. So it's not a multiple of 11 because the closest for 11 would be 33 or 44. And we know just from the multiplication table that when we multiply by 11, we, at least for the first 9 multiples, it's just the other factor repeated. Like 88 we know is multiple of 11, right? So since 37 is not showing that it's divisible by any of those values, we're going to say that this one is prime. So let's go to 29 then. So once again, in the ones place value, I have a 9. Well, 9 is not 0, 2, 4, 6, or 8, so it's not divisible by 2. So automatically, it's not divisible by 6 or 4. Also, I do not see that the 9 in the ones place value is not a 0, 5, or 0, so it's not divisible by 5 or 10. But is it divisible by 3? Well, let's find out. 2 plus 9 is 11. 11 is not a multiple of 3, so it's not divisible by 3 or 9. So we should check with 7, and the nearest multiple of 7 is 28. So it's not a multiple of 7. It's not a number that repeats itself, so it's not divisible by 11. Is it divisible by 13? Well, it's not on our list. And that's why we have the list there to help us out with that type of problem. So right here, we're going to say that it's prime. Let's go to 40 then. 40. 40 has a 0 in the ones place value, which means that it not only checks off with a 2 because it has a 0, but also 5 and 10. So since it has, it only needs 1 in the list that we have for the rules in order for it to not be prime. But this one has 3, which definitely makes it not prime. So we're going to show this one as composite. In fact, I'll color code these, so that's composite right there. Of course, you could just say not prime with the way this is worded, but I do want to specify that it's a composite type number because you'll see those types on the assignment. Okay, well, we can do 59 as well. So 59, once again, in the ones place value, I got a 9. Well, 9 is not 2, 4, 6, or 8, or 0, so it's not divisible by 2, 5, 10. Since it's not divisible by 2, it's not divisible by 6 either. Or 4 for that matter. So I need to check if it's divisible by 3. So let's see, 5 plus 9, what do we get? 14. 14 is not a multiple of 3, so it's not divisible by 3, which means it couldn't be divisible by 9. Excuse me. 59 is not a multiple of 7. The closest multiple of 7 that gets close to 59 is 56. You could say 63 if you'd like, either way. 13, yeah, it's not on our multiples of 13 that we showed here. And it's not a multiple of 11 because we don't get repeated numbers in those 2-digit type numbers. So yeah, this is a prime number. All right then. Well, 49, there it is again, another 9 in the ones place value. I don't know if they did that on purpose, but that means that it automatically eliminates 2, 5, 10, 4, and 6. So we should check to see if it's divisible by 3. Let's see, 4 plus 9. I get 13 out of that. 13 is not a multiple of 3, so it's not divisible by 3 and 9. Now, don't get this confused. Even though it's 13 right here, that does not mean it's a multiple of 13. It's just 3 that we were looking at. So I would go to the next one, which is 7. That would be the next one I check. Well, Is 49 a multiple of 7? Well, the answer to that is yes. That's the seventh multiple of 7. We could show that. Right? 7 times 7 is 49. So, since it is divisible by 7, again, that's not on the list, which is important to notice, of rules. So that's why it's important to have those multiplication tables memorized, at least for the first 12. That makes this one composite. Okay, that's pretty good. Well, what about 61? Well, 61, we end up with a similar problem like we've encountered. And the ones place value is an odd number, 1, which means right away we can eliminate 2. It's not divisible by 2, which means it's also, since it's a 1 in the ones place value, it's not divisible by 5 or 10. All right, so yeah, we know it's not divisible by 2. Oh yeah, since it's not divisible by 2, it's not divisible by 4 or 6, which leaves us with 3 and 9, right? Well, let's just check 3. That's all we really need to do. So I would say, okay, 6 plus 1, that's 7. 7 is not a multiple of 3. So it's not divisible by 3, which means it cannot be divisible by 9 either. So let's check our other numbers, right? 61 is not a multiple of 7, so it's not divisible by 7. 13, it's not in our list of multiples of 13, so that's not good. And it's not a repeating number in both place values, so it's not divisible by 11. So that means that this number 61 is also prime. So it's only divisible by 1 in itself. Well, what about 73? Let's check. Well, we got a 3 in the ones place value, which but that automatically eliminates 2, 5, and 10. And since we eliminated 2, it also eliminates 4 and 6. So we can check for 3 though, right? 7 plus 3, that's 10. 10 is not a multiple of 3, so it's not divisible by 3, which means in turn it is also not divisible by 9. So let's check for 7. Well, 70 is the nearest multiple of 7 that I can think of. So that won't work for 7. What about 13? Well, I got up to 65. Let's go to the next one. Add another 13. That makes 78. Now that's not 73 though. Yeah, it's not 73. So it doesn't work there either. And it would have to be 77 in order for it to be a multiple of 11. So since it's none of those that we've just gone over, then we're going to look at this one being prime. Now you should be asking, well, what about other values like maybe like 17 or 19, other weird values like that? We shouldn't be seeing any of those types at this point. The highest one we should have to check right now is 13, which is why I'm only doing up to 13 in these ones. Well, what about 88? Yeah, we can do 88. Let's see, 88. Yeah, in the ones place value, we got an 8. So right away, I see that it's divisible by 2. I should have erased this stuff, clean this stuff up. So it is divisible by 2. This one checks off. Therefore, this one is composite. 88 is composite. Now, just so you know, since this one is composite, and we know that it's divisible by 2 and some other values along the way, eventually we will find the other factors of these values. But right now, we need to get used to this vocabulary of prime and composite stuff. So that happens pretty quick, though, if we see an odd or an even number, rather, in the ones place value. We'll know pretty quickly if it's divisible by 2, 5, or 10. Because again, and the nice thing with that, it's just a visual check. Well, what about 79? All right, 79 does not have an even number in its ones place value, so it is not divisible by 2. The 9 in the ones place value means it's not divisible by 5 or 10. And since it's not divisible by 2, it's not divisible by 4 or 6 either. So we don't have to worry about those. See how that kind of eliminates some of those values? Just kind of directly. Well, is it divisible by 3? We should check. Let's go ahead and check. So I take 7 plus 9, which is 16. 16 is not a multiple of 3. So it's not a multiple of 3, so it couldn't be a multiple of 9 either. Is it a multiple of 7? Well, there's multiple of 7 is 77, so it's not that. Is it divisible by 13? Well, we see it's not the nearest one for 13 is 78, so that's no good. And the nearest multiple of 11 is 77. So it's none of those, which means, again, we're going to say this one is prime. So that was a lot of work, and that took some time. I understand that. But again, while we're getting used to this, at least if you need to get used to it, yeah, you should plan on these taking well, a bit of time. Okay, technology. There we go. So factors. If a number is prime, its only factors are 1 in itself, which we talked about. If it's composite, then it will have other factors than 1 in itself. So yeah, we start dividing the number by integers, 1, 2, 3, 4, 5, 6. Look for only the factors which have the remainder of 0. That's true. Or we can use the rules, which we're going to be using for the most part in this section. So stop once you get a repetition or you've tried half the numbers possible. That's true. That's good to know, because once you get halfway there, then you can stop, because well, it kind of meets in the middle, which we'll show you here in just a second. All right, find all factors of a given number. That's our objective, which is good. We want to find all the factors of these given numbers. Now, keep in mind, when it's asked for all the factors of these numbers, whatever number it's really talking about, not just these ones, is you should always start by listing 1 and itself. Okay, because automatically, because of the identity property of multiplication, and remember, that's what factors are, multiplication, we can list those two together. And all prime numbers, by the way, will have 1 in itself as factors. But are there any other factors of 15? So this is really asking, if you took two other numbers to multiply together, could you get 15? And yeah, hopefully, again, this comes with some familiarity of the multiplication tables, but yeah, I got 3 and 5 on that. So that would be 3 and 5. And we should know that it's divisible by 3 and 5. 5 because we have a 5 in the ones place value, and 3 not just because of the multiplication tables, but because 1 plus 5 is 6, which is a multiple of 3. Now, is it divisible by 2? No, it is not. So again, that automatically, since it's not divisible by 2, that eliminates 4 and 6. And since there's a 5 in the ones place value, it's also not divisible by 10. It's not a multiple of 7 or 13 or 11. Seems like I missed one. Maybe 9. It's not divisible by 9 because it's not a multiple of 9. So even though it is divisible by 3, we would have to take the other factor and see if it's divisible by 3. If it were, then it would be divisible by 9. But for 15, these are the only 4 factors that there are for 15. So what about 28? Well, again, just start with 1 in itself, 28. Again, from the identity property of multiplication. So are there any other factors of 28? So let's go through this, not like we did up here with just kind of almost guess and test, but let's apply the rules. So I see an 8 in the ones place value, which means it is divisible by 2. Now, while we may know what we need to multiply 2 by to get 28, if you don't know, it's okay. All you're going to do is take the number and divide it by the number we know it's divisible by, which in this case is 2. And whatever we get from this quotient will be the other factor, which is going to go on the other side. So 2 going to 2 one time, take away that 2, drop the 8, it's a 0. 2 will go into 8 4 times. So the other factor there, yeah, because we get a remainder of 0, which we should always get when we're looking at factors. The other factor there is 14. Now, is 28 divisible by 3? 2 plus 8 is 10. 10 is not a multiple of 3, so it is not divisible by 3. Now, if it is divisible by 4, you take this quotient here, the 14, and if it's divisible by 2, then it's also divisible by 4 because we already divided by 2. So 14 is divisible by 2, so I know 4 is a factor of 28. And to figure out what that is, you could use long division, but you should know your 4 multiplication tables at least up to 28. That's the 7th multiple, which gives you exactly nothing remaining on that 28. So that would be the other factor there, 7. But I'm going to point this out. See on the left how I kind of started with the two extremes, right? 1 and itself. And you see as we go to the left from, go to the right from the left, and as we go to the left from the right, we get closer together with these numbers. That's what it means when it's dividing by half. Which means that there shouldn't be any other factors between 7 and 14 or 14 and 28 because we're just going in order. 1, 2, we check 3, and then 4. 28 is not divisible by 5 because it doesn't have a 0 in the ones or a 5 in the ones place value. So it's also not divisible by 10. It's not divisible by 6 because it's not divisible by 3 and 2. So it is divisible by 2, but not 3. It needs to be both. And then we get to the 7. Well, we've already checked 7. 7 and 4 would work. And so again, you could start checking some of the other values between, but you'll find that it's not, those will not be factors. So this is our list, and maybe there's more space between the 4 and 7 than you'd like, but this is the list of factors of 28. All right, find all the factors of these ones. We're going to do the same thing with these. Find all the factors of these numbers. Now, 440 is a big number, excuse me, and in fact, we'll see that it has a lot of factors, which is okay. You should not expect to see any problems like this on the assignment where it has. I think this one has like 14 factors. We're going to find all of them, by the way, which is going to take quite a bit of analysis on our part. All right, so I'm going to take 440, and of course, my first factors are going to be 1 and itself. So factors, we'll just put a colon right there, 1 and 440. I'm going to try to write those small enough so I can fit all these other factors in between. Now I see a 0 in the ones place value, which means it is divisible by 2. So I'd say, okay, take my 440 divided by 2. 2 goes into 4 twice. 2 times 2 is 4, so that cancels that out. Drop the 4. 2 goes in that 4 twice, so that's another 4 there. I drop the 0. 2 will go into 0 0 times, so that's just our remainder, which is what we want, which means the other factor with the 2 is that quotient, which is 220. I should write that smaller because we got a lot of them to write in. Well, we can check if it's divisible by 3, right? Well, 4 plus 4 is 8, plus 0 is still 8. So 8 is not a multiple of 3, so I can't put a 3 in this one, which also means, obviously, that it's not divisible by 6 or 9. But let's check 4, all right? Now, again, you may not know your multiplication tables up to 4, but I know it's divisible by 4 because the quotient with 2, which is 220, that quotient is divisible by 2. So I know that 4 is going to be one of the factors. I just got to figure out which one it would be paired with. So I got 4. Let's divide that by 440. 4 goes into 4 once. 1 times 4 is 4. That cancels out. Drop the 4. 4 goes into that 4 once. 4 times 4 is 4. Subtract. Drop the 0. That's our remainder there. 4 won't go into 0. So the corresponding factor with 4 would be 110. All right, so this is a pretty good start. But as we move forward, we may have to kind of skip around. And yeah, we know since it has a 0 in the ones place value, it is also divisible by 5. Okay, well, what is the other factor that gets paired with 5? It should go next to the 110. See how, again, we're moving towards the middle from each of the ends. And that's good as long as we start with 1 and 440. So let's go ahead and take the 440 and divide it by 5 as well to find that other factor. 5 won't go into 4, but it will go into 44 8 times. 8 times 5 is 40. Subtract, we get 4 remaining out of that. Drop the 0 to make that 40. And 5 will go into 40 8 times. So that's 40 right there. Subtract, we get a remainder of 0, just like we want. So the other factor there would be 88. And again, this means if I paired all these colors together, the resulting product would be 440. 5 times 88 is 440, which is really what the long division shows. Now we know it's not divisible by 6. I'm kind of just moving my way up. Is it divisible by 7? No, it's not divisible by 7. And right now we don't need to worry about why, but it's not. Is it divisible by 8? Looks like it is. How do I know it's divisible by 8? That's because when I divided it by 4, the next multiple of 2 would be 8, right? 4 times 2 is 8. And 110 is divisible by 2. Now, let's say that you didn't know it was divisible by 8, which would be fine. Okay. Here's another way that I know it's divisible by 8, because in the factors, I see one number that I know is divisible by 8. So I'd be looking at these bigger ones specifically. 88. 88 is the 11th multiple of 8. And again, that comes with a little bit of recognition of knowing your multiplication tables. So I did check 6 and 7, but the next one for us would be 8. And yes, I know 440 is divisible by 8. And we kind of see that pattern there with the 5 over here. So let's take 440 and divide it by 8 and figure out what that corresponding factor would be. 8 won't go into 4, but it will go into 45 times. 5 times 8 is 40. So there's a 4 there. Drop the 0. 8 times 8 will go into 40 another 5 times. So subtract that one to get 0 remaining. That's good. So our corresponding factor with the 8 is 55. All right, that's nice. And there's another main factor I haven't gotten into, but that's 10, right? Now, we know 440 is not divisible by 9, which should be the next one we would check. But since it ends in 0, I do know that 10 is one of its factors. So let's include that. And, if you need to do long division on that, that's fine. 440 divided by 10. Some of you know you can just cross out the 0 and that'd be fine. But let's pretend like we didn't know that. 10 won't go into 4, but it will go into 44 4 times. 4 times 10 is 40. Subtract, we get the 4 there. Drop the 0. 10 will go into 40. Well, 4 times. When we subtract that, we get a remainder of 0. So 10 would correspond with 44. On that, we kind of see that recurring theme of the 11, right? 44 is the 11th multiple of 4. 55 is the 11th multiple of 5. 88 is the 11th multiple of 8, which means that we know that it also should be divisible by 11. So we can do the long division again. 440 divided by 11. 11 will go into 44 4 times. 4 times 11 is 44. Subtract, you get that cancels out the 44s, and so you got the 0 remaining. So it looks like the other factor there is just 40. I still didn't give myself enough space, so I'm going to have to kind of write some numbers above there, which is okay. So you could check 12. It's not divisible by 12. Is it divisible by 13? No, it's not divisible by 13. And again, you don't have to worry about saying, well, is it possible you may have to do long division with some of this guess and test stuff? Yeah, you may, right? Like you'd say, well, divide it by 440 by 13, and you'll get some type of remainder on that, which is not really what we want. We should be seeing only remainders of 0. But just for the sake of time, I'm going to skip that long division, even though you just need to know that you may have to check that on the assignment. But what about some of these other values? Well, it's not divisible by 13. It's not divisible by 14. It's not divisible by 15. Or, is it divisible? Nope, it's not divisible by 16. 17 is one of those weird ones. It shouldn't be divisible by 17. Is it divisible by 18? Possibly, but the one that I'm really trying to get to is 20. 20 right? 20 has a relationship with 40 and 220, so it should have a relationship with 440. So, and we can check this again. You just may want to check it if you needed to. Just take 440 and divide it by 20. 20 won't go into 4, but it will go into 44 twice. 2 times 20 is 40. See that recurring theme of 40 there. I don't know if that's really on purpose, but it shows the relationship between some of these values. And there's another 40. 20 will go into 40 twice again. So subtract that 40 out, and we get a remainder of 0, just like we want. And so in between the 11 and 40, I would have to fit this in, but I'm just going to write it above. 20 and 22. Now, you see how we got really close together with the 20 and 22 there? You could try 21, but 21 times 21 is not 440. And yeah, how many was that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16. 16 factors of 440. So keep that in mind that you should not see any examples on the assignment that include 16 factors. But I think it's a really good exercise. I used a little bit of our rules that aren't really part of the rules we went over. So again, if they kind of fall out of those, especially once you get out of 13, then you shouldn't expect to see too much of this kind of stuff. I would consider this kind of a freak example because we shouldn't see it too often, all right? So let's go to 117. We shouldn't see a lot of factors of 117, but again, you can only start with 1 and itself, so that'd be 1 and 117 right there. Now, in the ones place value, we see the 7, and it's okay to see a 7 there. It's just, since it is a 7 in the ones place value, it's automatically not divisible by 2, 4, 5, 6, or 10. So the next value I would check is 3, right? And I'd say, look, 1 plus 1 plus 7, right? So 1 plus 1 is 2, plus the 7 is 9. And 9 is a multiple of 3. So I know that it's divisible by 3. And to figure out which multiple this is, I would just take the 117 and divide it by 3. 3 won't go into 1, but it will go into 11 3 times. 3 times 3 is 9. Subtract 2 remaining, drop the 7, make that 27. 3 goes into 27 9 times. So the other factor that pairs with 3 would be 39. 3 times 39 is 117. Now again, we just saw just from the 2's that it's not divisible by 4, 5, 6. Is it divisible by 7? It is not divisible by 7. I'm going to skip the math on that, even though you could check with long division. It's not divisible by 8 because it's not divisible by 2. Is it divisible by 9? Well, yeah, when we added the numbers together, we got that 9 right there. So we do know that 9 is one of the factors, which is good. Let's go ahead and check and see what the other factor would be that pairs with that, though. So 117 divided by 9. 9 goes into 11 once. 1 times 9 is 9. I did skip that first one. We get the 2 out of there, drop the 7. 9 will go into 27 3 times. So yep, that shows a remainder of 0, just like we want. And our other factor there is 13. But see how close those got together, 9 and 13? So you could check 10. Well, it doesn't end in 0, so it's not 10. Is it divisible by 11? No, the closest multiple of 11 is 121. And then that it's not divisible by 12 because it's not an even number, but that brings us to 13, which is the next factor, and it's already one of our factors in the list that we have. So this list of factors of 117 is complete. 1, 3, 9, 13, 39, and 117. So 53, again, in the ones place value, which is where I should start, I get a 3. That is an odd number, which means that it's not divisible by 2, which means it's also not divisible by 4 or 6. Since it's a 3 in the ones place value, it's also not divisible by 5 or 10. So we need to check 3. Again, that's the next one we should check. So I just add the two numbers together. 5 plus 3 is 8. 8 is not a multiple of 3. So it's not divisible by 9 either. Well, is 53 a multiple of 7? No, it is not. 56 is, though. So that's not a multiple of 7. Is it a multiple of 13? Well, what do we get? 13, 26. By the way, it's not a multiple of 11 because the numbers don't repeat for two-digit numbers. 39, 52. That's pretty close, but it's not quite there for 13. So we checked all the values really that are on our list, and we saw that none of them check off, which means that the only factors of 53 are 1 and itself. And just going back to what we started with, since the only two factors of 53 are 1 and itself, this number is also prime. Now, you didn't have to write prime on that last one, but I just wanted to reiterate that it is prime because its only factors are 1 in itself. Write that out. So a factor tree, very effective method, and I highly recommend that you use it. Now, to use a factor tree, just start with the number that we're looking at here, which is, again, it's a product, right? So we're starting with that product, which in this case is 182. And to start out the factor tree, you only get two branches out of every number coming out of the factor tree. And yeah, you can call these branches whatever, however you like to, to refer to it. But branches is good because we're looking at a tree. And all we need is two factors of 182. Now, we don't have many multiplication tables memorized up to 182, and that's fine because then we can just use our rules for divisibility, right? I could say, look, 182 is their number I know is divisible by that 182 is divisible by. Well, I got a 1 and a 2 in the ones place value, so I do know that it's divisible by 2. All right, well, what would be the other factor? Well, we're gonna have to do some division to find that out. 182 divided by 2. 2 won't go into 1, but it will go into 18 9 times. 9 times 2 is 18. So that zeroes out, and we'll drop the 2. 2 goes into 2 once. So subtracting that 2, we get a remainder of 0, just like we want. Boom, 91. Now 2 is a prime number, and once you get prime numbers, that really ends the branch right there. And I recommend circling those values so that you understand that that branch has ended and that you now have a prime number as well. So that leaves us with 91. We need to see if this is prime. It kind of looks prime, right? But let's just double check. 91, again, the ones place value is a 1. So it's not divisible by 2, 4, 5, 6, or 10. Is it divisible by 3? Well, 9 plus 1 is 10. So it is not divisible by 10. I'm sorry, 9 plus 1 is 10, which means it's not divisible by 3, because 10 is not a multiple of 3. Which means it's also not divisible by 9, and we should understand that. It's not divisible by 11. 91 is not a multiple of... No, is it 13? We'll see. The number I'm really thinking about is 7. Okay, I don't know if 91 is a multiple of 7, which I think is an easier number to check than 13, because we should have our 7 multiplication tables up. So let's see if this will branch out with 7 as one of the factors. Okay, so I take 91 and divide it by 7. This quotient will tell me if there is another factor, but I have to have nothing remaining after I divide this. 7 will go into 9 from the 91 once. 1 times 7 is 7, so that subtracts out to give us 2. Drop the 1, yes, 7 will go into 21 3 times, and there's that 13. 3 times 7 is 21, so we get a remainder of 0, just like we want. And then we get 13. Now, if we go back, we know 7 is prime. 13 is also prime because they are only divisible by 1 and themselves. So, our final factors, and this says input the numbers prime factors in ascending order. Ascending means you're going to list them from smallest to biggest, which, and I didn't really do this on purpose, but they're already in ascending order from left to right. So we have the 2, and the 7, and the 13. These are all prime numbers, and they are all factors of 182. Now, this also means, since we're looking at prime factorization, that if you were to take 2 and multiply it by 7, and then multiply that by 13, you would get 182. So these are our 3 prime factors of 182. So I just want to find the prime factorization, and I'm gonna use 180. 180 is a really good number because it lends itself to the question you're going to see on the homework. So 180, let's use prime factorization, and this is another good use of the factor tree. So I take 180, and the first thing I would notice on this one is the 0 in the ones place value. So not only is it divisible by 2, but I know it's divisible by 10. Now, on that last problem, I started with a 2, which is prime. You could put a 2 right here, by the way, right? You'd have 2 and 90. The truth is you could use 3 or looks like 4 as well. And there's just a bunch of numbers you can use. I'm using 10 just because that's the first one I noticed, because in the ones place value I have a 0. And the nice thing about that is I don't really need the division because its other factor is just the same number but without the 0. That makes that 18. So both of these, neither of these are prime, which means that I can further split both of these up. How do I know they're not prime? Because I got in the ones place value, both numbers are even numbers, 0 and 8. So I know that 10 is divisible by 2, which is prime, so I got that circled. 10 divided by 2 is 5, so that's our other factor. 2 times 5 is 10. That's good. Well, what about 18? Well, 18, I know it's divisible by 3 because 1 plus 8 is 9. So I'm going to make 3 one of those factors. You could have said 2, by the way, and that would work. But I'm going to use 6, 3 and 6. But again, I'm pointing this out. You could have used 2 and 9 on this. But the only other factors we can use is 6 and 3. Again, you would not use 1 in itself because 1 is not prime, and we're looking for prime factors. So 6 will split up into 2 and 3 again, like this. All right? And 2 and 3 are both prime. Now I'm going to list these from least to greatest. So that would be 2, there's another 2, there's 2 3s, and then the 5. Now just understand, the way this works on the homework is that you would not list them this way. So yeah, this will not work in the homework the way that we have this written. Like we see in the homework, it says use exponents for repeated factors, right? And remember, exponents are repeated factors. Factors is multiplication. Exponents is repeated multiplication. So be sure to use that asterisk between the factors. That's fine. But for this example that we're doing right here, 2 times 2 times 3 times 3 times 5, yeah, we have some of these factors repeat, right? For example, the 2's repeat. That's 2 times 2, so it's a base of 2. How many 2's are being multiplied? There's 2 of them. So the exponent is 2 as well. Well, we got 3's that repeat also, so that's a base of 3. How many 3's are being multiplied together? There's 2. So that's 3 to the power of 2. The 5 is just 5. There's no other repeated multiplication with the 5. So we're just going to put multiplication between these. And now that we have it written like this, 2 to the power of 2 times 3 to the power of 2 times 5 is really what this is looking for on the homework. Now you'll see problems like this on the assignment as well. Find all factors of a given number, given that 6 times 7 equals 42. Now remember, this is multiplication. The 6 and 7, that's multiplication between those two, which means 6 and 7 are both the factors, and 42 is the product. Now I do want to relate this with the fact families. Okay, so 42 is the product, which means that it has to be the dividend in the division problem. So I got 42 divided by, again, it doesn't matter which of the two factors becomes the divisor. So I can make that 6, which means that the quotient is the other factor, which is 7. Now that's just one of the facts in the fact family. I can also write the other one by switching the two factors, right? So I could say, look, the divisor now is the other factor, which is 7. 42 divided by 7 is the other factor, which is 6. And these three facts in the fact family is going to help me to solve or make the determination on which of these statements are true or false. So first off, it says that 42 is a factor of 6. Interesting thought right there. Well, if it is a factor of 6, that means that you would have 42 times something equals 6. Okay, that's what it means to be a factor of something. And I can't multiply anything other than, and again, in the fact family, that should be a 7 right there, but it's not. 42 times 7 is definitely not 6. But it would be a fractional value right there, so that's no good right there. Okay, which means that this is definitely false. So I'm just going to cross that out. I'll put a check marks in the ones that are true. But the next statement says 42 is a factor of 7. Well, just like 42 is a factor of 6, this would show 42 times something is 7. And just based on our fact family, that value should be 6, but it's not. That does not work. That is false. So that means that this statement is also false. Well, what about 6 is a factor of 42? Yes, that's what this statement shows. 6 is one of the two factors of 42. So this one is going to check off. There's our check mark. I've done better, but that seems okay. The next statement says 7 is a factor of 42. Yeah, that's the other factor right there, 7, right there. So I'm going to give this one a check mark as well. That one is true. Now this next statement, 7 is divisible by 42. That means that 7 has to be the dividend, specifically. So you'd say 7 divided by something. Oh, well, I apologize. 7 divided by 42 can be some kind of natural number, which, again, just based on the fact family, shouldn't be 6. But we know this is false. Right there, 7 divided by 42 is not 6. Now, if you switch those, it would be true, but it's not switched. And order does matter with division, so we're going to cross that one out. That one is false. There we go. 42 is divisible by 7. Yep, that is true. That is exactly what this statement is showing. 42 divided by 7 gives us a natural number. Check mark on that one. That's true. The next statement, 42 is divisible by 6. Yep, that's this statement right here. 42 divided by 6. 42 is divisible by 6. That gives us 7. So that one gives us a true statement. Next up, 6 is divisible by 42. Again, it's kind of like what we have up there in orange. That's like saying 6 divided by 42 could equal some natural number, but it cannot. Again, it should be 7, by the way, but that's not part of our fact family. So that is also a false statement. So here we go. This one starts with a 27 divided by 9 equals 3. We want all of the statements that are true. So I'm going to show the fact family on this one, right? So 27, that is the dividend. Right now, 9 is the divisor and 3 is the quotient. That means that for the multiplication problem, you'd have the divisor, that's one of the factors. So it would be multiplied by the quotient, which is 3. And that would equal the product, which is the dividend in the fact family. So 9 times 3 is 27. However, that's only 2 of the facts in the fact family. Well, remember, if you took the dividend at 27, you can switch the divisor and quotient, meaning that the other fact would be 27 divided by 3 equals 9. So this gives us the full fact family, and 9 is a factor of 27. From our factor statement, which is the multiplication statement, 9 is one of the factors. So I can check that off right away. Boom, check mark. The next statement, 27 is divisible by 9. Yes, that's exactly what this statement shows. That is also a true statement. 9 is divisible by 27. Again, it's kind of related to this one. It's just that it switches the dividend and divisor, which wouldn't equal 3 anymore because this is directly related to the fact family. So this one is false. Cross it out. Next statement, 3 is a factor of 27. That's exactly what the multiplication shows. 3 is one of the two factors of 27. So yep, this one gets a check mark. This next statement, 27 is divisible by 3. That's exactly what this statement shows. 27 can be divided by 3 to be some natural number. So yeah, that one gets a check mark as well. 27 is a factor of 9. Nope, I don't see any of these fact families that show 9 times 27. I'm sorry, 27 times something equals the product of 9. Again, that of means you're looking at the product. So this one is a false statement. Next, 27 is a factor of 3. Again, that means that you'd have to have 27 times something, which would equal 3. And again, I can't get a natural number out of that blank, which means that that is also false. 3 is divisible by 27. Again, the order of this is crucial because we're saying 3 can be divided by 27. I mean, it can, mathematically speaking, but not when we're talking about natural numbers and factors like this. And again, the idea on this is to make the fact family where that would be a 9, but it doesn't equal 9, so this is a false statement. So we had 4 true statements on that one. I think that's pretty good.